All right, we're going to get started. One thing that I had mentioned in the video that I posted last week, and I think I sent a message through Infinite Campus and through Schoology, is the note packets. Again, copies are made. They are available in the main office. I don't know how much longer they're going to leave them there before they put them in the recycling. There are a lot of copies left. So if you didn't get a packet and would like one, you can do that. Pick them up as soon as possible, though. Just kind of nice to not have to write down everything here. There is also a PDF copy of the blank notes in Schoology. I will show you that after we're done with notes today. If you have a printer and want to print them yourself, you can certainly do that. Sometimes just easier to pick up the printed copy, save yourself the money for paper and ink. All right, so we're going to start 4-1 today. We'll finish it up on Thursday. And then next week you will have a quiz on 1-3 and 1-4. So today we're going to look at graphing absolute value functions. So on the top of the page here is just the regular absolute value of X. That great V shape for absolute value function. And what I'm going to do is I'm going to graph a couple of absolute value functions, and we're going to jot the graph in our notes. And what we're looking for is what happens to the graph as we add and subtract inside the absolute value function. So I am going to graph that first one, y equals the absolute value of x minus 2. And those of you who suffered with me last trimester or in the past know I love to use the TI-84. That's the calculator I'm very familiar with. You can use Desmos as well. All right, so absolute value on the TI-84 is in the math menu, and you have to arrow over to num, and it's the first option, abs. And I want to do x minus 2. And so that my graph looks the same as what's going to be in the packet, I'm going to change my window. Window, it goes from -6 to 6. Not -3, -6 to 6, and from -3 to 5. There we go. And I'm going to graph. So we should jot that graph in our notes. I actually changed my graph so that it's blue. All right. Then we're going to graph the absolute value of x plus 1. So again, going to my calculator, and I am going to Basically, I went over to the equal sign, I pressed enter, and it shut off the graph of that first function. And the reason I did that is when I've done these three, I want to take a look at maybe comparing what happened. So we have x plus 1, and we're going to graph that one. So again, we'll jot that in our notes. There we go. And then x plus 3, the absolute value of x plus 3. All right, see if I can do this. I don't know what happened there. All right, x plus 3 and graph. And there's that absolute value function. So the next thing we're asked is, do you notice any patterns? So I'm going to go back to my calculator, and I'm going to make sure all three are being graphed at the same time. So what patterns do you notice with that absolute value graph? Obviously, it's V-shaped, and that's just because it's an absolute value. But what do you notice about what happens to the graph as you add or subtract inside the absolute value? So this is your turn to answer. So what pattern, what happens to the graph as we add or subtract inside of the absolute value. And if you would like, you can certainly use the chat feature. It's set so that the only person that can read the chat is me. So you will have anonymity. So if I have the absolute value function, so in black, this is just the normal absolute value function. If I can draw it right. So what happened when I subtracted 2 inside the absolute value function? What happened to the graph? Yeah, it moves to the left. And what happens when I add 1 inside the absolute value function? Oh, wait a minute now. I'm going to take that back. So what we're looking at is going from the graph that's in black to the graph that's in blue. That doesn't move to the left, it moves to the right. Yeah. And so when I add 1, it moves to the so it moves to the right when I subtract 2. It moves to the left when I add. So the pattern, oof, our graphs moved either left or right. All right, now we're going to take a look at the second set. So if I go back to my calculator and I'm going to clear those out. Now we have the absolute value of X. And the -2 this time is outside of the absolute value. Excuse me. And we'll graph that one. And let's put that in our notes. right? Now we're going to add 1 outside of the absolute value. So again, I'm going to turn that one off and just graph the next one by itself. And there's the graph when we add 1. Put that in our notes. All right. And then we're going to do absolute value of x minus 3. So as I'm graphing that on the calculator, I want you to make a guess. What do you think is going to happen? Anyone think they know? All right, excellent. Excellent, yeah. So there's our graph for absolute value of x minus 3. So we'll jot that or sketch that in our notes. And I already had a great answer for what happens here. The graph moves up and down. We're going to be a little more specific about that here in just a moment. But so adding inside moves us left and right. Adding outside moves us up and down. All right. So today on 1-4, we're doing transformations of absolute value functions. And what we're really looking at are how do the values of a, h, and k affect the graph of the absolute value function f of x is equal to a times the absolute value of x minus h plus k. All right, so absolute value, if you remember, of a number is just its distance from 0 on a number line. So because it's distance, distance is never negative. So the absolute value of 5 is 5. What is the absolute value of negative 7? Feel free to unmute and just shout it out. Excellent. Those that are using chat, absolute value of negative 7 is 7. Absolute value of 0, well, 0 is 0 units from 0 on the number line. So the absolute value of 0 is 0. When we talk about the absolute value function, when we graph it, it is a V-shaped graph. And we call y equals the absolute value of x the parent function. In other words, that's the most basic of the absolute value functions. And then we can move it all around by adding and subtracting and doing other things with it. The highest or lowest point is called the vertex. And that's going to be kind of where we start with our graphing. We always want to try to start at the vertex, and it makes things easier as we move from there. A transformation changes a graph's size, shape, position, or orientation. And we'll talk about orientation in a little bit. I think size is pretty self-explanatory. Shape, again, pretty self-explanatory. Position, so we could move it left, right, up, down. And then the orientation, so for the absolute value function, it's a V shape. We could do something and make it upside down. That would be orientation. One type of transformation is a translation. And a translation is a transformation that shifts a graph horizontally or vertically, but does not change its shape, size, or orientation. So a translation is like shifting, just a moving of the graph. Everything else stays the same, just its placement on the axis is different. So what we're going to do is we are going to graph the parent function, y equals the absolute value of x. So if I plug in -4 for x, what is the absolute value of -4? -4 is 4 units away from 0. So the absolute value of -4 is +4. Absolute value of -3. +3. Absolute value of -2. +2, yep. And then we'd have 1, 0. And then what happens when we take the absolute value of positive numbers? What's the absolute value of +1? Yeah, exactly. Nothing changes if it's already positive. So one way to graph this is just plot each point. -4, 4, -3, 3, -2, 2, -1, 1, 0. 1, 1, 2, 2, 3, 3, 4, 4. And it continues forever in both directions. All right. But we could change that. We could do some transformations on that function. So if I have y equals a times the absolute value of x minus h plus k, the a is kind of like the slope or the shape of the v. If a is less than 0, if it's negative, the graph flips over. It would become upside down. If a is between 0 and 1, it compresses the graph. It makes it open wider. And if a is greater than 1, it's a stretch of the graph. It opens, it's going to be narrower. For h, if we have x minus h in the absolute value, we go to the right. And here's the way that I remember that. Minus M-I-N-U-S, 5 letters. Right, R-I-G-H-T, 5 letters. So right and minus. If we have x plus h, we move to the left. P-L-U-S plus 4 letters. L-E-F-T, left, 4 letters. So that's one way to remember that. K, if k is positive, if we add k, we're going to go up. If we subtract k, we're going to go down. That's pretty, I hope, seems pretty standard or pretty self-explanatory. So the vertex, the most important point of the whole graph is the vertex, and it is whatever h is and whatever k is. So we need to be careful. If we want to just graph the vertex, we have to do whatever is the opposite of what's in the absolute value, and the y coordinate for the vertex is exactly what we're adding on the outside. All right, so for each graph each absolute value function, state the vertex, transformation or transformations from the parent function, and then give the domain, the range, and the intercepts. So the vertex is where we're going to start. The x coordinate of the vertex is the opposite of what we're doing inside the absolute value. What is the opposite of plus 6?
Never mind. Minus 6.
You got it. You got it. Awesome. And the y coordinate is whatever we're adding outside of the absolute value. In this case, we're not adding anything. So the transformation, instead of starting at 0, 0, we start at -6, 0. So we moved 6 units to the left. And we're going to call it a shift. Shift 6 units left. Once you have the vertex, the rest of the graph can be pretty easy. There's no value, there's no number in front of the absolute value. So from that point, we go up 1 over 1 in both directions. And we can make as many points as we want. Now, in your homework, you're going to be asked to make at least 2 on each side. So I did a few more than 2 on each side. I really Did a bad job graphing. That's better. All right. Domain. What X values can I plug in and still get an answer for this problem? The key here is going to be the arrows on the end. If we draw arrows so it goes off in both directions, the domain is going to be negative infinity to positive infinity. For range, I always look at what is the lowest Y value. So the domain is my X's, the range is my Y's. And one thing you could do is think, okay, here's where it's at its lowest. What is the Y value there? Like for this point, what is the Y coordinate? Zero. And because we could have zero for Y, we use a square, that square bracket. And then what's the largest value we can get? Again, the arrow goes off and it just keeps going. So we could go all the way to, we call it positive, or I put a negative in there, that's not good. Positive infinity, because there's no bound. It goes and can get as high as it wants to get. Okay. X-intercept, where does it cross the X-axis? So the X-intercept is where Y is 0. The Y-intercept is where X is 0. So what's the X-intercept? What is that value right there? Yeah, negative 6, 0 is the X-intercept. Try to write that a little better. And the Y-intercept right up here. That is positive 6. Good. All right. Let's go to the next example. Okay. Here now, we've changed, we're subtracting 4 from X inside the absolute value and adding 3 outside. So my vertex, I take the opposite of this, so the opposite of minus 4. And this I don't change. So instead of having the vertex at 0, 0, my vertex is at 4, 3. So my transformation, shift right 4 units. And up 3 units. Again, there's no number in front of the absolute value. So the graph, we're just going to go over 1, up 1. In both directions to get that wonderful V shape. I'm going to give you a little hint on domain for absolute value. Absolute value for the domain is always going to be negative infinity to positive infinity. The range, it's my y values now. What's this lowest y value? And it goes up forever. All right. Where does this graph cross the x-axis? What is the x-intercept? And let's see, if I look down here, I don't see it cross the x-intercept anywhere. So we just say there are none. Where does it cross the y-axis? Yep. 0, 7. All right. Next example. Vertex. What am I adding inside the absolute value? Ooh, okay, never mind. What am I adding inside the absolute value? Nothing. Outside of the absolute value, I'm subtracting 2. Now I do have a number in front of the absolute value, so I'm going to wait for the transformations until I graph and the way that I'm going to graph this, I'm going to use this just like a slope. So just like slope, rise over run, I'm going to go up 1 over 3, up 1 over 3, up 1 over 3. I'm going to do that in both directions. So there are 2 transformations here. We shift down 2 units, and there's a compression by a factor of 1/3. So this number out front tells us the factor for the compression. If it was greater than 1, it would be a stretch. What's the domain going to be? Because it's an absolute value function. You're going to have to unmute because I don't think there's a way to do the symbols in the chat. Sorry. Negative infinity to positive infinity. The range. What is my lowest y value? And it goes up forever. So in other words, what this means is you could give me any value greater than -2, and I should be able to tell you what number to plug in for x to give you that value as an answer. All right, x-intercepts. In this case, we cross the x-axis twice. What are the x-intercepts? -6 and +6. Excellent. And what is the y-intercept? Excellent. -2 is correct. All right, so that one changed a little bit. We put a number out in front. We called that A at the beginning. So we had A, and A was not 1. All right. Here we go again. So same directions. Graph, state the vertex, transformations, find the domain, the range, and the intercepts. So -1 tells me go right 1. The -3 on the other side says go down 3. In this case, I have a -2 in front of the absolute value. That's like -2 over 1. So I go down 2 over 1, down 2 over 1, down 2 over 1. As many times as I want. So the transformation actually, I think is real easy when you look at the vertex. If the vertex has a positive x coordinate, that means we shift right 1 unit. If it was negative, we'd shift left The y coordinate, if it's positive, we go up. If it's negative, we go down. Excuse me. The -2 does two things. It's a stretch by a factor of 2. And because it's negative, it is a reflection. All of that from that little graph or that little function. The domain, again, of all absolute value functions, negative infinity to infinity. The range, now we're looking what is the smallest value. And there isn't a smallest value. So the range is going to go from negative infinity to whatever the largest value is. In this case, we do have a largest value. The largest value is -3. What is the x-intercept? None. What is the y-intercept? Yep, excellent. -0, -5. And again, on the homework and on your quiz that you're actually have next week, you'll be given like the 0 coordinate. You'll just have to plug in the -5. Yeah. So technically the y-intercept is the point 0, -5. Most people just say -5, which I think is kind of right, but it's not quite right. But again, on your quiz and on your homework, you're going to have that 0 there. You'll just have to supply the y value for the y-intercept, the x value for the x-intercept, and if it's none, you'll just put none. All right, coming down to the end here. Again, graphing this vertex. +4 means I go left 4. -3 says go down 3. There is my vertex. The 3/4 for the kind of the slope go up 3/4. And then draw that in. As good as I can anyway. All right, So the transformations, again, the x coordinate is negative, so that means I went left 4 units. The y coordinate is negative, so I went down 3 units. This value in front of the absolute value is a fraction that's less than 1. So it's a compression by a factor of 3/4. Domain, hopefully you're getting that pretty easy. The range, now this time, I have a lowest value, I have a minimum. The lowest y value that I could have is -3, and it can go any value above. So we say -3 to infinity. X-intercepts. Where do we cross the x-axis? Whoops. Well, there's one place that I cross the x-axis. There's another place that I cross the x-axis. So I have 2 x-intercepts. And where do I cross the y-axis? I only have 1 y-intercept at 0, 0. So one of the interesting things, if your x-intercept is 0, 0, then your y-intercept will also be 0, 0. All right. So what I'm going to do is stop recording.